Hi, I'm wondering, have you ever thought, I wonder why it is that a balloon sticks to my head when I rub it against my hair? Or what the heck are those little electric shocks that I feel in the wintertime when I shuffle my feet on the floor? Or maybe you're wondering if you could levitate something? Or it could be that you're just wondering what this crazy contraption is here on the table. Well, we're going to get to all of that on this edition of Make It Monday. My name is JoAnn, and I'm one of the educators here at the Ecotarium. We are a museum of science and nature in the heart of Worcester, Massachusetts. And today, we are going to discover some really cool things about static electricity. Now, first of all, when you have a balloon and you rub it against your hair, and then you lift it off, your hair, oh my gosh, sticks to the balloon. But why does that happen? Well, it all has to do with the movement of electrons. Now, electrons are those really tiny particles that are part of atoms. And atoms make up everything in our world. Now, atoms have two charges. They have electrons, which have a negative charge, and protons, which have a positive charge. And some things, like this balloon, readily accept extra electrons. And your hair easily gives away electrons. So when you rub the balloon on your hair, the balloon becomes more negatively charged, your hair becomes more positively charged, and you know what? These opposite charges attract. So, what about when you shuffle your feet on the floor? Right. So what you're doing when you're rubbing your feet on the floor, especially during the winter time when it's really dry, you're transferring electrons from your body to the floor. So you become more negatively charged. And then when you touch something that is positively charged, those two charges, again, want to attract. And they want to equal out. And then you might feel a little bit of a shock. Now, this machine next to us here is really cool. This is called a Wingster Machine. And what it does is it separates electrical charges. So, by rubbing a piece of copper wire on these plastic discs, it makes one side more negatively charged and the other side more positively charged. And this goes all the way up to these little silver balls at the top. And what happens with opposite charges? Right, they attract. So what I'm going to do is open these up and we'll start spinning. Well, that's really cool. Let's see what happens when we turn out the lights. Here we go. Do we think we can make that a little bigger? Let's find out. One more. All right, there we go. Wasn't that super cool? So that was just the very tiniest little bit of lightning and the smallest little thunderclap you ever did hear. Now I also mentioned levitation. Now this is something that you can do at home. The only things you need are a piece of PVC pipe, a plastic grocery bag, a pair of scissors, and a piece of wool fabric. So what you're going to do is use your scissors to cut out a piece from your plastic bag. I made mine look kind of like a squid. And then you're going to lay that flat on the table. And then you're going to take your piece of wool fabric and rub it in one direction several times across the piece of plastic. So what I'm doing is transferring electrons. And now we're going to do that with our piece of PVC. Again, rubbing it in the same direction to build up an electrical charge. Now, watch this. Take your little plastic squid, toss it up in the air, and then you can use this as a magic wand. Should we try that again? Take your plastic squid, set it on the table, and then take your piece of wool fabric and rub it in the same direction on the plastic squid. So what you're doing here is you're transferring electrons from one thing to the other. So now you know this is working when it starts really sticking to the table. So now we've built up an electrical charge on the piece of plastic, and we're going to do the same thing with our piece of PVC pipe. Again, piece of wool in the same direction. Also, make sure you use the same piece of fabric too. Building up an imbalance of charges. Great. Now here we go. Toss your squid up in the air, and then use your wand to levitate your squid not using the power of magic, but using the power of science. Now, why does this work? Well, for the same reason that your hair is attracted to the balloon, and that our Wingster machine shows you a tiny bolt of lightning. Now in these cases, opposites attract, right? But you know what? Like charges repel. So by using the cloth on both the piece of plastic and on the PVC pipe, they're both going to be positively charged. And those positive charges want to push away from each other. So to review, opposite charges attract and like charges repel. So you can use the power of science to do a little magic trick. So join us again next time for Make It Monday.